Hi, this video will show you how to solve the Michaelis-Menten equation for one of the parameters if you know the other ones. So in this case, we have the Michaelis-Menten equation here. We have the Vmax equation, which is Kcat times enzyme total. And then we have all the values that were provided in this problem. So we're going to solve for S. So if you look at the parameters that were given, we have nanomolar, nanomolar, and micromolar. And that's because biochemists like to have numbers bigger than 1, so they will change the unit so they can get a number larger than 1. But in order to solve the equation here, we have to have them all in the same unit. So I'm going to convert those to micromolar. So we'll look at this one first. If VO equals 500 nanomolar per second, that will equal 1,000 nanomolar for every 1 micromolar, and we'll get 0.5 micromolar per second for initial velocity, or VO. So you're essentially just taking the number and dividing it by 1,000. So we'll go ahead and convert those up here. So this is going to equal 0.5 micromolar per second. This one is not a concentration, so we can leave it as is. The enzyme total is nanomolar, so that will equal 2 divided by 1,000, which is 0.002 micromolar. And then Km is already in micromolar. Now we can put these numbers in and solve for S. So VO is equal to 0.5 micromolar divided by seconds. And then instead of putting Vmax in, I'm just going to simply put the Kcat times ET in, or enzyme total. Kcat is 600 per second. So that goes here, times enzyme total, 0.002 micromolar, times S. So that's that part. And then we divide by Km, which is 5.75 micromolar, which is here, plus S. So that's the thing we have to solve. So in order to solve that, let's get rid of the denominator. So we'll times both sides by 5.75 micromolar plus S. 5.75 micromolar plus S. And that will cancel out. So now we have 5.75 micromolar plus S times 0.5 micromolar per second equals this. I'm just going to do the math here. So 600 times 0.002 equals 1.2 micromolar per second. And that will be times S. So now we're going to have to combine these terms. It'll be 5.75 times 0.5 micromolar per second. So that will equal, that will equal 2.875 micromolar squared per second. So we times this by this. So half of that is 2.875. We have 2 micromolar, so it's squared, and it's over second. And then we do these two, which is a simple 0.5 micromolar per second S, and that equals 1.2 micromolar per second times S. So now we can subtract the 0.5 micromolar per second S from both sides. We take 1.2 minus 0.5, and we get 2.875 micromolar squared per second equals 0.7 micromolar per second S. And then the last thing we do is we divide both sides by 0.7 micromolar per second. So that goes away, and then here we get the seconds cancel out, and one of the micromolars cancels out, so that 2.875 divided by 0.7 is equal to 4.1 micromolar, and that will equal S. Or for sig figs, substrate concentration will equal 4 micromolar. So that's your answer. And then if you want to double check it, you can just take the 4 micromolar for S and put it back into the original equation with the other values, and it should equal your VO concentration, which was, or rate, which was 0.5 micromolar per second. So that's how you do rearrangement and solving for a parameter in the Michaelis-Menten equation. If you have any questions, let me know.